topic for today. My topic is going to be, well, the shift from XML to Compose only. So yeah, I recently switched projects where I had a chance, it was completely new project and I had a chance to go with Compose only. And I'll talk a little bit about why did we chose that at the first place, then some adaptations in our, how is the project set up, what are some adaptations in architecture that we needed to do, something about navigation, and at the end we're going to talk about pros and cons in general. So yeah, let's start. See if this is working. Okay. So first things first, why did we choose Jetpack Compose? If you open the documentation, you see these nice things. So like build better apps faster with Jetpack Compose, less code, intuitive, accelerates development, and those are all like just some nice words. And usually when I read the documentation about Android for the first time, well, yeah, I'm in doubt if that really works or not. So we said, okay, we need to put that into the test. So on a more serious note, as I already mentioned, the project was completely new, so it made sense to use the latest tech stack. Besides all of that, the Compose is getting more and more exposure. There's more and more libraries around it. There's more and more talks, I don't know, blog posts, videos, so you can get help more easier. So yeah, the next thing, community seemed to accept it well as well. And what's most important, it promises faster and easier UI development. So everything is in Kotlin, there's no more XML, which you can also assume that there will be less code in the end. Moving on, we figure out that the declarative approach of Jetpack Compose fits our architecture better. So in Infinum, we mostly use MVVM or model view model. And this is, let's see if, okay. So this is the presentation, let's say a picture how this works. We have UI elements, those are our buttons, text fields, and so on, the things that users see and interacts with. Those things produce UI events that flow up to ViewModel. ViewModel does something with that and produces UR state that flows down to the, well, UI back. And in imperative approach, that meant we need to provide some step-by-step instruction on how to modify UI. You probably remember that getting an ID of a button and then calling set text, set color, set background color, whatever, then getting another ID of title and again setting text. And like sometimes the order of that matters. And if you mess up that order, you will end up in a weird UI state that you don't want. And yeah, with the declarative approach, that's not needed anymore. We only require a description of our UI. We pass that down to our Compose, and the Compose will display that thing for us. And what's good? Well, we already have the description of our UI. That's our UI state. So, as I said, Compose eliminates the need to manually manage UI state and handle UI updates, which leads to less bugs in the end. Okay, moving on to the last thing. We noticed that mobile community is shifting towards the declarative UI. So with Flutter having widgets right from the beginning, with iOS community slowly shifting towards Swift UI, those are all declarative approaches. So it's way easier to onboard developers from other platforms. If, for example, somebody worked with Swift UI, it's way easier to onboard him to Compose than to if we would start like teaching him the XML thing. And of course, last but not least, it's a shiny new thing. And we really wouldn't be developers if we wouldn't want to try everything new. So, okay, that's it. Moving on to our project and architecture setup. And first, the project setup, just a quick overview. We only use single activity, so no fragments at all. There's just single activity and a bunch of composables under it. And then we use Coin for dependency injection and data store for persistent storage. That's not that important for this presentation, but I just wanted to mention because you're going to see later that some view models are injected, and yeah, we use Coin for that. And let's first see like a high overview or like abstract view and difference between Compose and XML. So on the left side, we have Compose. And we have one main activity, so that's the only activity. And below that we have main navigation, we have login screen, home screen, toolbar, and etc. A bunch of things. And this is like all of those components, so all of the green boxes, they are all composables, which means everything is in Kotlin. And on the right side we have an XML. And let's see how things looks on this side. First, we have our main activity, we have our two fragments, in this case login and home fragment. Each of those fragments have their layouts, and then there's toolbar and text field. This is done in XML, and we have our custom button that's, well, custom view. And if somebody if you ever did a custom view in Android, you know how hard, or not really hard, but time consuming it is to create a custom view. While on Compose side is just, you like copy part of the composable that you did, you extract it to another composable, and you have your custom view that you can use like throughout your app. So this is if you are lucky, and if you're not lucky, you even have more activities here, and of course more fragments. But like if you have more activities, then you need to handle communication or navigating between activities, and those activities usually have then multiple fragments underneath them again, and so on and so on. So this all meant that we should just go with Compose since it's way nicer. Okay, moving on to our architecture setup. This is a quick overview of our architecture. It doesn't really make much sense, so from this picture alone. So we're gonna take a look at each of the components on its own in a moment. But in a sense, we have our base view model that's extended by each of our screen view models, and there wasn't really much changes in that, so I'll explain what these view models are responsible for. But what's new in our approach, since we chose Compose only, was this BaseComposable that replaced our base fragment that handles some things. And BaseComposable, wraps each of our screen composables, and it's used at all screens. To explain this a bit more in detail, we'll see each of the components on its own. But first, let's talk a bit about state and events. So when I'm talking about state, we have two types of states. First is a view state. This is a representation of our UI. And it's a screen-specific state. For example, login screen uses login state, and there are, disabled button, enabled button, whatever. Then we have our common state that handles our loading and errors. So this is, let's say, things that can be done only once and that are just like similar across the app. And on the other side, we have events, where again, we have two types of events. One, I call them UI events, and those are the events that are flowing up. I'll just show the image here. Those are the events that flow up from UI elements to view model, so UI events, and those are button clicks and text input and so on. And then we have the events. Those are the events that go from view model to UI elements, so we need to add events here. And those are usually used for things like navigation, showing toasts, showing snack bars. And there's like never-ending story of whether we should use events at all or not. Google recently recommends that we shouldn't use them. They should be part of state. I won't really go into much details between using states or using events or not in this talk, because it's just a huge topic on its own. But in this case, we decided that we still want to use them since they make some things more intuitive. Okay, moving on, let's first take a look at our base view model. This one is just responsible for creating, updating, and exposing our view state, common state, and events channel, while it also stores initial view state, so the state that is going to be displayed whenever you navigate for the first time. And it also handles our common state, that's loading and errors. Let's see how that looks in code. As I said, base view model stores initial state here, and then just flows and channel for events. But as I said, there's nothing much changed here. let's take a look at BaseComposable instead. This one is responsible for, well, yeah, it starts collecting the events. It also starts observing view and common state, and it also handles the common state. Let's see again the code. Yeah, the BaseComposable takes in 3 parameters: view model, events handler, and the content. But we'll see how each of those are used in a short. And let's first take a look at the event collecting. So, since I mentioned, yeah, we still have events. Let's take a look at how are they handled. We first get the events flow from the view model. We also get the current lifecycle owner, so that's the owner, I mean the BaseComposable lifecycle, and then we use launched effect. And if some of you maybe have already worked with Compose, you probably know that you use launch effect whenever you want to do something for the first time when your composable is shown. You can, let's say we can compare it to activities on create, for example, where you initiate some stuff. And then for the keys, we pass in events flow and lifecycle owner, which just means that when either of those two will change, this thing, this block inside will run again. And yeah, inside we just start collecting the events. And okay, we have this line here that just says that we repeat that whenever the lifecycle is started. It's not that important. But what's important is that this piece of code will trigger the event collection only once. So why am I telling that? Before we achieved that piece of code, we started with this one. So if you Google something, let's say you Google how to do something in Compose only once, so or at the start, you will get this piece of code. So you use launched effect with unit. And if you already work with Compose, there's a high chance that you already use this. But what's the problem with this thing is that if you navigate to this screen multiple times, so let's say you have screen A and B, you navigate from A to B and then back to A, this will be called twice, which will start event flow collecting twice. And that's not that big of a problem if you just use it for navigation, since navigation is triggered once and, well, the screen is not in effect anymore. But you can quickly run into issues with snack bars or toasts, or yeah, because they can be shown multiple times. So if you use events, yeah, this is the wrong approach, and be careful to not do that. Moving on, as I said, BaseComposable is responsible for our common state handling. And what do? We get the common state from the view model. We use the collect the state with lifecycle. That's the newest method that they added. We get its value, and yeah, we just observe it. If it's idle, we don't do nothing, and we do nothing. And if it's a loading, we just display loading overview, which you see here. This is a bit misleading since it's all black, but in reality it's transparent, so the user can see what's behind it. And we do almost the same thing with the errors as well. I decided not to show that here, but yeah, we observe them, and instead of the overlay, we display a dialog. But just to be a bit quicker, a bit shorter, I decided to skip it. And let's take a look at the view state. As I said, one of the BaseComposable's parameters is this content that needs state. We also observe it, we use the same method, and we just pass in the state. Okay, that was a bit technical. I hope I didn't lose you, but I hope it will make more sense now, where we can see how the general screen structure looks like. And we'll take login screen, for example. It gets 2 parameters. First one is on user logged in. That is used for navigation. We're gonna see navigation a bit later. And the other is view model, which is just injected. Then, as I said, we use BaseComposable at every screen. We pass in our view model, and there's also our events handler that handles the events, of course. And lastly, we have our state. So the thing between this block is our state, where basically we get the state here. In this example, login screen has login state, and the only thing that's inside of that is this has internet connection attribute. and it can be null, false, or true, and depending on which state this is, we just display a different thing. So those loading overlay, no network overlay, and login web view, those are just composables declared literally anywhere, and this, yeah, whenever state changes, this is reflected on Compose. This is what I mentioned earlier, where you just get you pass in the state and Compose renders everything for you. Moving on to the navigation. And yeah, let's start. So for the navigation, of course, since we don't have fragments, we decided to use Compose navigation. And if anyone was already working on with Compose navigation, you probably heard about, or like there's a lot of talks about them. There's a lot of blog posts that it doesn't have type safety for arguments out of the box. So there are some third-party libraries that support or like that handles this, but we decided not to use them. So how did we handle that in the end? Well, we just don't use them. We don't use arguments when navigating. We usually fetch data from data store upon navigating, which means that you have one screen, you save everything to data store that you need on the other screen. Then you do navigation, then you fetch data and display it. So we can argue which approach is better or faster, let's say, but yeah, of course the faster approach is with the arguments, but we didn't notice like any, how to say, the loading that takes the data that's loaded from the data store and the time needed for that is just like unnoticeable for the user, so we decided that this approach works for us the best way. And moving on, let's see how our navigation is looks like in code. This is really a simple, how to say, almost a copy from the thing that you're going to see in every documentation about Compose navigation. So we have our composable called main navigation, and that's our top level composable that we use. Then we instantiate nav controller, we use nav host, we pass in nav controller, we choose the start and destination, and inside of that there's just a bunch of composables with their own routes, and yeah, you use navcontroller.navigate to navigate between composables. That's, as I said, pretty standard setup, but okay, yeah, if somebody was already worked with that, you know that you need to use strings, but we decided to just create a sealed class in this case called screen and use a string as a parameter to make things a bit nicer instead of writing direct strings everywhere. Okay, before we switch to problem that we encountered with this, there is this on-user logged in, as you can see, or yeah, we already saw that on general screen structure, and this is lambda used for navigating. And what was the problem that we encountered, for example, on a settings screen? Well, what we would need to do in this case, we would need to pass in, well, lambda for each of the buttons, which in this case means 10 lambdas. And how would that look like as a composable? Well, there would just be too much parameters. And how did we solve that? Yeah, this is a wrong approach. How did we solve that? Well, we chose to only pass one lambda on navigation action and pass in some settings to navigation action in this case. So let's see what is this navigation action. Well, it's almost a copy of the class that we saw on a couple slides ago, the screen one. It also takes in the root, but it's just like named a bit differently. So it's called navigation action in our case, and this is also like two actions that extend this. So back and open web page, and those are some general navigation actions that can be triggered on most of the screens. As you probably know, like back, there's usually possibility to navigate back either by a press of a button or gesture navigation. And what's good then, well, we can have our screen-specific navigation actions. So in this case, settings navigation actions that extends navigation action, and then you put all of that lambdas that we saw earlier. Well, we create objects for each of that, and then you just call on navigate from the screen, and you pass in the action, and let some other class handle this. So what's this class? We called it Navigator. That's just like a custom class. Takes in the nav controller, only has one method called navigate that gets in the navigation action, of course. And depending on this action, well, yeah, you do something. So if it's back, you pop a back stack. If it's open a web page, well, you open a web page. Otherwise, you just navigate to the root. So let's see what do we need to do on our navigation graph. This is the thing that we saw earlier, but we need to add our navigator, of course, and then this thing will change. So instead of using nav controller directly, well, we replace that and use our navigator and his only navigate method. And then with this approach, well, every screen can just have this on navigate, and you just declare a bunch of actions, which are then handled by navigator. Okay, lastly, coming to an end slowly, pros and cons about the whole setup. So for the pros, we figure out that it's, well, much faster UI development. And as I mentioned already a couple of times, there's less code since there's no activities, no fragments, no XML. And with that said, we can confirm that documentation is right this time, at least. I'll also show you the little experiment that I did in the end to show you the example of this. And but yeah, let's move on. We also notice better UX in some cases, and I also have examples for this one, so stay with me. And then live preview. Of course, a live preview sounds nice, but it usually doesn't work. So I listed it also under cons. But if it works, it's a good thing. But like 90% of the time, it doesn't work. So if they get it up working, for example, let's say 90% how the Flutter one works, it will be okay. But currently, you usually just get those render issues, and then you have to build the whole project again, which takes almost the same time as building and running the app on your phone. So yeah, there's that. And in the end, yeah, it just feels right. So everything is in Kotlin. You don't have to do this context switching between XML and fragment, and then layout and custom view and so on. Everything is Kotlin, they're just composables. And yeah, cons, navigation, of course, one of them, since it feels it's a kind of step back as opposed to navigation between fragments that we had before, and live preview that I already mentioned. And then there are also unknown performance issues and unknown stability issues. And yeah, since they are unknown, I can't really talk much about them. And we'll see. I just hope that we won't run into any major issues that would need some refactoring. Okay, and now to the last things. So those better UX cases that I mentioned. One thing that we really notice that's a great thing is language changing. So if you have like in-app language picker, that's also like a hot topic if you need to implement it. It's like, especially in XML, it's not that easy to implement. Or let's see how that looks like in XML first. So we choose German, and then you have this weird animation. It's also a bit laggy, but you see that the screen shifts, and yes, of course, because the activity needs to be recreated. And Compose, and well, we don't need to recreate the activity, so this is how it looks like. You just choose it, and everything's like automatically translated for you. There's no this weird flickering and recreating and so on. So that's one nice thing. The other one was theme changing, also the same thing. So you press a button, you change the theme, you don't need to recreate activity again. I don't have the example from XML here. It's also possible to achieve that, of course, but with way more work. With Compose, it's really easy. You need to set up different theme, of course, and the only thing that you need to do is reference colors from the theme on each of the objects, or buttons, text and background and so on, and then you implement mechanism for theme switching, which is maybe at most 30 lines of code, and well, you have it working. And lastly, so UI development, let's say speed comparison or just comparison between the two. I decided to make a really simple screen. So we have an image, we have text, button and a list. Which in XML means recycler view, of course. And now I measured the time of doing these two things and the lines of code at the end of the whole screen. And also we have to take in account that, okay, I've been working with Compose now for what, let's say a year, and I'm quite comfortable with it. While also XML is, with 3 years of experience. I know, for example, that for recycler view, you need to add recycler view, you need to implement the adapter, you need to create an item view. So just so that we take these results with a grain of salt. Because if somebody would work with the recycler view for the first time, the numbers are of course quite different. But okay, for the time spent, does anyone have a guess or would want to guess what's the difference or how much did it take for one and the other?
8 times faster.
8 times faster. Yeah? Anybody else? If not, it's not 8 times faster because it's really simple, but still, for Compose I needed 4 minutes and 30 seconds, and for XML it took me like 14 minutes. But as I said, I also haven't worked with XML in a while, and even just this simple recycler view took me, let's say, 10 minutes. So, but of course, when you do some more modifications, some more, let's say, styling of the components, it gets complicated. So.
But the button on the Compose one doesn't have all caps.
Yeah, that's correct. So it would probably.
If you would add that, it would be longer than 4 minutes.
Yeah. Good point. No, maybe the thing that I forgot to mention is that they only put like the default things that we get, so the default tags, the default buttons, and displayed. Because this is just that we have comparison between the two. So I didn't set all caps here or lowercase here. Just
I'm kidding because it takes a while to
to make it all caps.
Yeah.
Or I wouldn't say so. In Compose it would be
Yeah, no, unless they changed it.
I think it's.
You have to create a font and have it give it a style and stuff like that.
No, you don't. But okay, you know.
Okay.
Just the text. So if you put in the all caps, it will be all.
Oh yeah. If you put the text all caps,
Yeah, sure.
That's true.
Okay, and then the lines of code. So this is the end result. So 58 for Compose and XML 101. So this takes in the activity, the minimum activity with Composable, while on the other hand we have activity with the layout, adapter, and the recycler view item. So also not that big of a difference, but it can grow quite large if you do more things, as I said. And with that, that's it. Is there any questions? Maybe. Yep.
Just curious about the navigation because I kind of didn't understand what you did there. You're actually not passing even a single ID. So, for instance, like a classic example would be a details view.
Yeah.
You're actually avoiding passing the ID and not doing that through data store?
Yeah, that's correct. I mean, we don't, in our case, there is no such screen. I was thinking about that before the talk. There's no such screen that we would need an ID. But for example, we need to display user details, and we just save that to like repository that stores, let's say, first name, last name, and email.
Yeah, makes sense.
But like if you would need that, of course, passing an ID is not a big of a deal. So.
You would probably prefer passing an ID versus data store for data, but ID in the URL.
Yeah, correct.
That makes sense.
But you want a clean state, right?
Sorry, what?
I mean, you don't want to pass any,
Well,
source of truth.
Yeah, that's correct. But like passing an ID would just mean you get an extra, how to say, data. Yeah, extra data when you start the screen, and then you do something probably with it in a view model, which again produces the state. So, yeah. Anything else? Carlo.
Did you ever regret using Jetpack Compose? Did you think, oh, if I was only building this in XML?
For now, not really. The project is under development now for well, almost a year actually. So, but yeah, currently we don't have a, yeah. It's like the time needed for UI development is such like shorter or smaller that just that it's like huge plus. So
I have a question.
yeah.
No, go.
No. Yes, first.
No. You go first.
Okay, so actually I have 2 questions. Both of them are hard. So which one do you want first?
Just go with it.
Okay, so I know for a fact that you're also working on a project that still uses XMLs and these.
Yeah.
How do you handle the context switching between Jetpack Compose and views?
Yeah, well, a good question. So I already had some issues, as I said, when working with this simple example. So yeah, it's kind of hard, but still, you switch back to XML. You need like, let's say, an hour or 2, and you're back. So depending on, of course, how much experience do you have, but yeah, it's.
But do you think that it's going to be hard for new developers, let's say, 2 or 3 years, which are normally versatile in Jetpack Compose, to work on older XML code?
Well, I would say probably yes, at least noticeable. So this was already noticeable, for example, if somebody is only working with Kotlin and then you put it into a project that uses Java or literally anything. So we can compare Eric's Java with coroutines or Dagger and Coin and such stuff. So there's always this.
Yeah, but you have ChatGPT which can translate from one thing to another.
Yeah, that's also one thing that helps us now. So we'll see.
That was the sub question, so I also have a second one. So we all heard in the beginning that you also work with Flutter and that you also work with Swift UI, right?
Yeah.
So
no, Swift UI not really, but
okay,
Flutter, yeah.
Like, can you mention one thing that, in your opinion, the Jetpack Compose does better than Flutter or Swift UI, and one thing that it does worse? It could be anything.
Good question. Well, Flutter, it's not really. Well, yeah. I mean, performance. Of course, performance on the Compose is better if we just look at the application in the end. But I mentioned the live preview. So that's really, I think that Flutter is winning currently here, even though, yeah, I don't really have any data for Swift UI since I worked with storyboards there. But yeah, otherwise, currently, I would really have to, again, step back into Flutter to compare things in more detail. But like state handling, I would say, is also a bit clearer in Compose, but that could just be my way of work and the things that I'm used to. So yeah, it's a bit biased, I'd say. Then you had a question, yeah?
Sure, a few questions. First one, BaseComposable, why?
Why? Well, as I said, it just takes in some things that you don't want to repeat on all of the screens. So events collecting, states collecting, and such stuff. And also, yeah, it's like the display of loading screen and all the errors. You just, in each of the view models, for example, we just have show loading, and BaseComposable takes care of that.
I understand. Okay, second question. Thank you. Live previews. You said 90% of the time they don't work. What are you previewing? The screens, the content of the screens, or the composables?
Well, that depends on each of the cases, let's say. So usually you have multiple previews, of course, but sometimes that's the preview of the whole screen, sometimes just a composable, and those work really nice. But usually when you do a full screen preview, then yeah, it's better to build it on your phone. And
okay. Because for the screens, that I think it's a recent approach to have like a screen and then the content of the screen that accepts as a parameter a state.
Mm-hmm.
So then you can just pass that state and have a preview whatever you want. And I mean that's how we do it.
Yeah,
I'm asking, like, if you're gonna do it like directly, if you have like a, I don't know, view model or have a hilt view model or whatever, then you have to initiate like a both view model, then it's a problem.
yeah.
With you. Okay. Let's see. I have another question.
Yeah, go ahead.
Okay, you said like for the events that you're sending events and not state, and that's your preference for now. Okay, you didn't try just with state,
We did.
and you didn't like it.
Well, the main problem that you have with that approach is, so let's say we have a login screen and then you pass in a Boolean flag, so is user logged in. That means that when that's true, we navigate to our next screen. And then you navigate back, it navigates you, like you navigate back from, okay, that's not the best example since you usually don't want to navigate from home screen back to login, but let's say just possible in this scenario. You navigate back to login and it immediately navigates back to the home screen. And why? Well, because you forgot to reset the Boolean flag to false. And then you need to handle that manually. I know that same thing as with arguments for navigation. There are libraries or third-party things that handle that. That you don't need to manually take care of that, but it's still a bit, how to say, pain in the ass that you need to handle that state resetting manually. So Google recommends that can actually be just a flag in UI itself, but we also didn't find that really, how to say that, it's kind of, I had a feeling that this is a bit too error prone, so we decided not to use them.
Okay, sure, but it's tested. Like you can't get in a like limbo state if you have like only state and no events. It's just that's like a pro for only state. But I understand completely. Like I've done it like that with events because it's like way easier.
Yeah.
And it's like one time event, do it, then you're done.
Yeah.
One more for Navigator. You said that you have like a Navigator. Did you have like multiple Navigators for multiple screens, or did you have like just one and that's like it?
Well, it's just one, but it's not that big since we only have like 3 or 4 actions that are that can be used. So the one was back and the open web page and so on. Those are used across all. Otherwise, you just navigate to the root of the action. So
Okay.
it's maybe a 30 lines long class. So, but yeah, it's only one.
One con about that is like you can see what does it do? You have to go into the Navigator, you know. But one thing that I like about if you come to the main screen that navigates, I don't know, to the login, to the main content, you can see okay, where can I get from the login content?
Yeah.
Where can I get from the main content? And that's like a very
Well, I would agree to some point, but for example, in our case, you just go onto home screen, you see the home screen navigation actions, there's a help clicked or a login clicked, so and then you just see where is that in your navigation graph set as root, and this is where you'll navigate.
I understand when you did that. It's like more simple, more clear. Okay.
But yeah, that was just like one of the first tries, so it's definitely, I mean, it probably can be improved, so. Okay, anything else, maybe?
Did you try to test in composables?
Good question, but not yet. It is maybe in plan, but currently not, so.
Even Google did, so.
Okay.
Oh, one more.
Yeah.
Why corn and not hill?
Okay, good question again, but let's say that the application uses SDK that's also developed by, let's say, us, and the SDK also uses Coin, and then we usually have to switch between the two, so just to make things a bit more consistent, we use Coin. I tried to use Hilt at the beginning when creating the app, but it just made things worse, so that's, let's say, the main reason.
Doesn't matter.
Yeah. Okay. Thank you, everyone.